Hi, so the next part of this module, which would be module 1 under unit 2, is graphs of equivalent ratios. Okay, so in this one, you can see our learning target. And our learning target is I can represent a collection of equivalent ratios as ordered pairs and graph the ratio relationship on the coordinate plane. So just quick vocabulary check as to what the coordinate plane is, what are ordered pairs, etc. So we are getting into graphs of equivalent relationships. So when we are talking about what a coordinate plane is, it's the coordinate system, and it comprises of the 4 quadrants, quadrant 1, 2, 3, 4, that go in the counterclockwise method. But right now, we are just going to be focusing on your quadrant 1, where your ordered pairs are positive, positive. And then we'll talk about what an ordered pair is. An ordered pair is written within a parenthesis, and it comprises of an x and a y coordinate. I'm going to show you that in a minute. And then, of course, the x-axis is your horizontal axis, and your y-axis is the vertical axis. And then the origin is where the ordered pair is 0, 0. And so let's quickly, go into the graphs of equivalent ratios. And I have a question for you. I've set it up in a table over here. So we are going to use this. All right. And so to make a simple salad dressing, you can use 3 cups of olive oil, which I'm going to use as Y, and for every cup of vinegar, which I'm going to use as X. All right, and then you can add herbs, salt, pepper for seasoning. So this relationship I have put into the form of a table right now. Okay, and so what we're going to do is each pair of equivalent ratios that we have, these can be expressed as an ordered pair. Okay, so here's an ordered pair. So for when x is 1, y is 3. So here is my first ordered pair. So ordered pair is written like this. It's written within the parentheses. The first one, so this is an ordered pair. Okay, and the first one is called the x coordinate. Okay, the first one is called the x coordinate in the ordered pair, and the second one is called the y coordinate. The y coordinate. Okay, so we know that x always comes before y. So in any ordered pair, we always write xy in that order. Okay, so there is my first ordered pair. What's my second ordered pair? Is 2 and 6. All right, so here's my second ordered pair, which is 2 and 6. The third one is 3 and 9. Fourth one is 4 and 12. And the fifth one is 5 and 15. Okay, so these are my ordered pairs. And so each pair of equivalent ratios can be expressed as an ordered pair. And of course, the x coordinate is representing the number of cups of vinegar, and the y coordinate represents the number of cups of olive oil. And to graph a point, what do? We start at the origin, and then we move right along the x-axis and the number of units indicated by the x coordinate. All right, so let's start a graph first. So we have salad dressing. We know that x is what? It is vinegar. So I am going to make the x-axis, and x-axis goes in this horizontal direction. All right, and so this is vinegar, and the cups of vinegar, so that is this one. Okay, and then what goes vertically is my y-axis. Vertically is my y-axis, and over here that's being represented by olive oil. Okay, so this is olive oil, and then of course that is cups of olive oil that you're talking about. Okay, now we know that the origin is where? Over here. Okay, where the x and y meet, my ordered pair is always 0, 0. So that's where the origin is. And I am going to have the same intervals. If I'm having 1, 2, 3, 4, I cannot do 1, 5, and all over the place. So the intervals have to be the same. So since I'm talking about the cups of vinegar, I'm going to go ahead and do it this way. This is 1 cup, 2 cups, 3 cups, 4 cups, 5 cups, 6 cups, etc. Okay? And then for the olive oil, I am just going to go ahead and let me do by intervals of 2, 4, 6, 8, 10, 12, 14, and I can take it one more, and this is 16. This is 16. All right? So I've got to label the x-axis. I've got to label the y-axis so I can see what it is representing. And we are talking about over here, we have salad dressing. This is salad dressing. Okay? All right, so there is my heading over there. So now let us start graphing it. All right? So we always look at which axis first? We always look at the x-axis first. All right? Because that is the number of units indicated by the x-coordinate. And then from that location, we move up along the y-axis, which is the number of units indicated by the y-coordinate. And we place a dot at that location. All right? So do not try to climb before you walk. So first walk, then we climb. X always comes before Y. So please remember that when you are plotting. Okay? So let's look at the first ordered pair. The first ordered pair is 1, 3. So we look at x first, the x coordinate, which is here. This is x. So this is 1, and so then we go up. All right, and this is y now. So if this is 2, this is 4, where is 3? 3 is going to be here. And I do this, and I put the dot, and I circle it. And this is my ordered pair of 1, 3. All right, then let's look at the second ordered pair. The second one is saying 2, 6. So this is 2, and I'm going to go to x first again. There's 2. And there is 6 on the y. Where they meet, that is my ordered pair, which is 2, 6. Okay? Next is 3, 9. So once again, start on x. And this is 3. If this is 8, there is 9 is over here. Okay? And look, where they meet, there is my 3, 9. This is always x. This is y. X, y, x, y. All right, and then for 4, we go from here again, and we have 12, and so this comes from this side. Okay, and so this is my 4, 12. 4, 12. For 5, we have 15, and so here we go. This is 5, and this, if this is 14 over here, we know that 15 is over here. Okay, so here we go. This is my 5 and 15. All right, but that's basically how graphing is done. All right, and this is a graph of an equivalent ratio. As we can see, it's going to form a straight line because it's proportional. All right, in this case, and so you might notice that to travel from each point to the next point, what are you doing? You are moving up 3 units to the right 1 unit, okay? Up 3 units, right 1. Up 3, right 1. Up 3, right 1. So that's basically what is happening in this one, okay? So these are the same numbers in the ratio of 3 cups of olive oil for every 1 cup of vinegar, all right? So let me take you for another question. to the board. And here is, okay, so graph ratio relationships in this one. Tamara is making charm bracelets for several friends. She uses 6 beads for every charm. And generate the set of ordered pairs for the ratio relationship between the number of beads Y and the number of charms X for a total of 1, 2, 3, and 4 charms, and then graph the relationship. Okay, so I'm going to go ahead and make a table on, so that you've seen the question. I'm going to go ahead and make a table for this, and let me just make the table here and then I'll graph it over there. All right, so that you have the question in front of you. Okay, so when we are making a table, here we go. I'm going to make this table over here. And it's saying charms is X, all right, and number of beads is Y. Okay, so this is charms, which is my X coordinate, all right, and just change the color so you can see better with this. Charms is X, all right, and beads is Y. And then it's asking for 1, 2, 3, and 4 charms. Okay, so it's asking for 1, 2, 3, and 4 charms. So 1, 2, 3, and 4 charms. Okay, and then since it's talking about 6 beads for every charm, so 6 beads for the first, and we are going to keep scaling up to complete the table to write the equivalent ratios for 2, 3, and 4. So for 1 it's 6, for 2 it'll be 6 times 2, which is 12, for 3 it'll be 6 times 3, which is 18, and for 4 it'll be 6 times 4, which is 24. So now we have this already written out. The table is made, okay, and so therefore we are using the scaling to complete the table, and then after that all we are doing is we are going to graph this, and this is my X, which is my number of charms. Okay, so this is my number of charms, and then this is Y, okay, which is the number of beads. This is the number of beads. Okay, and we are talking about 4 charms. So this is 1, 2, 3, and 4. And for beads, I'm going to go ahead and I am going to make intervals of 3, 6, 9, 12, 15, 18, 21, 24. So I've made intervals of 3. Okay, and so for 1 I have, so here are my ordered pairs. Okay, my ordered pairs are 1 and 6, 2 and 12, 3 and 18, 4 and 24. So remember, X before Y. And then I just take these and I plot it. So for 1, let me take a different color to plot. I can use this color. So for 1, I have 6, which is here. This is 1, 6. For 2, I have 12. So this is my 2 over here. Here's my 12. So this is what I do. 2 and 12. Okay, for 3 I have 18, and that's where we plot it. Okay, 3 and 18, and for 4 I have 24. So here, okay, 4 and 24. So there is my graph. Okay, so we're graphing it on the coordinate plane. Yeah, all right. So let's do one more, and this is the last one that I'm going to show you as an example. Let's look at this. And with this one, I'm just going to take you through the steps which have already been solved, but I still want to show this to you. To make one batch of homemade modeling clay that can be used in arts and crafts, Sequoia mixed the ingredients shown in the table. So this is what she's mixing in the table. All right. Graph the ratio relationship between the number of cups of water, which is here, which is, it's saying water is Y, all right, and cups of flour, which is this. This is going to be X. So this is X and this is Y. And for a total of 5 batches, all right. So we are then going to first describe, how to make the table. So we know that for the first, if you're going to generate a table for this, what am I going to do? I will look at these two, right? So let me show it to you really quick just because of shortage of time. So here we go. Let's look here. And this is how I'm going to create it. So as I was telling you, 4 cups of flour to 2 cups of water. And then I'm going to create an equivalent ratio. So this is for 1 batch. For 2 batches, it's going to be, I'm going to double this. 4 times 2 is 8. Same thing here. 2 times 2 is 4. So that's for 2 batches. For 3 batches, I do 4 times 3 is 12. And 2 times 3 is 6. I'm using the multiplicative structure that we talked about. Okay, that's for 3 batches. For 4, you'll do times 4. So I get 16 cups of flour to 8 cups of water. For 5 batches, I would multiply with 5. So 4 times 5 is 20 and 2 times 5 is 10. So now I have created, my ordered pairs by scaling up. All right, so then we have our ordered pairs, which are, what is the first ordered pair? Is 4, 2. The second ordered pair is 8, 4. The third ordered pair is 12, 6. The fourth ordered pair is 16, 8. And the fifth ordered pair is 20, 10. And once we have created our ordered pairs with the table, because that's an equivalent ratio table, we are going to convert it into a graph. So I'm just going to show you a graph that has been created using these ordered pairs. All right, so here we go. So there is my graph that has been created. So look, for 4 cups of flour, 2 cups of water. 8 cups of flour, 4 cups of water. For 12 cups of flour, we have 6 cups of water. For 16 cups of flour, we have 8 cups of water. For 20 cups of flour, we have 10 cups of water. Okay, so that's how we are creating this graph. Okay, now if I had to describe the pattern in the ratio relationship, so in the graph, the points appear to fall on a straight line, right? So each new point is 2 units up from the 4 units to the right of the previous point. Okay, so 2 units up, and we have, as you can see, it's 2 units up from and 4 units to the right of the previous point. This means that the number of cups of water increases by 2 cups as the number of cups of flour increases by 4 cups. Okay, So that's basically what it represents. Once again, how is the water increasing? It is increasing by 2 cups, as the number of cups of flour is increasing by 4 cups. Okay? All right. So that is basically what this lesson is about. It's just using your tables of equivalent ratios and then extending it further to convert it into a graph. Have a great day, everyone.